this video, I'll be doing a detailed solution to the maths question you see on the screen here from 2024 Cambridge A-Level mechanics paper, specifically paper 4.1. If you're looking for a different question from this paper or a different paper entirely, check out the description below for links. And if you find this video or any of the videos on my channel useful and you want to help the channel out, what helps the most is sharing this video, especially if you're in a class group with other people sitting the exam. Also, I do appreciate likes, subscribes, or even a super thanks. In question 4, we're told all about a car pulling a trailer. We're told lots of numbers and we're asked to find certain things at the end. Let me draw roughly what they're telling. They're telling us about a car with a trailer and how do they phrase it? Inextendable cable. That's a magic cable, a cable that doesn't get stretched, doesn't lose any energy in it. It's magic cable, and it's pulling a trailer. They tell us the weights of these two. There's 1,700 is the car, and the trailer is just 300 kilograms. What else do they tell us? The car is connected parallel to the road, constant resistance of motion. Okay, so the car has there's something resisting the car, air resistance, and that's 400 newtons is working against the car. The trailer then has 150 newtons working against that. The power of the car's engine is 14,000. So it's driving it forward, 14,000 watts forward. They want us to find out the acceleration of the car and the tension in the cable. That's actually the harder part of the question. The acceleration of the car, I'll hopefully show you now, isn't all that difficult. The cable is the slightly harder part. Oh, also we have newtons, and watts. So let's change this first. The formula for power. Power is force times velocity. Yeah, of course. Force times velocity. So that means they give us the velocity, didn't they? Yes. Sorry. The car is going at 20 meters per second at this moment in time, at least. So the force is equal to power divided by V, which is 14,000 divided by 20, which is just 700 newtons. So this engine's driving it forward 700 newtons. There's resistance of, 550 newtons. So really, if you forget about this trailer and car and rope and just think of this as one big object that's 2,000 kilograms, we know it's being driven forward by 700 newtons. We know it's being pulled back by these two. Add them together, that's 550 newtons. So when they ask about acceleration, well, I know this is the same as something being pushed forward with, what's the difference there? 150 newtons. Because these can just add together forces. 2,000 kilograms. So we have force, we have mass. We're only looking for acceleration. Force is equal mass times acceleration. A is equal to force divided by mass. A is equal 150 divided by 2,000, which is equal 0.075, I believe, meters per second squared. Let me just double check that. Yeah, 75. So that's half the answer. But like I said, that was the easier part of the answer. Whenever you can do this, do it. If you can combine two things together to one object, it's much easier. Like think of a stone falling down a hill. That's easy. Imagine working out the equations for every atom in that stone. Not difficult. We know this guy was going forward. We know the cable couldn't stretch anymore. So we're allowed to treat it as one guy. Anyway, that's the answer for the acceleration. It's not that hard to find the tension in the cable. We just have to understand it a bit more. So how the tension in the cable works, it's pulling the trailer, T, but it's also pulling the car, T. Obviously the car is being pulled itself by its engine and it's a lot heavier. So the fact that this tension is barely pulling the car, whereas the trailer is getting pulled a lot. It's a lot lighter and it doesn't have its own force working. Well, it has its resistant force helping it. So what you can do now to find this tension is to look at either of these worlds. We can look at the car on its own, because T's in there. We understand everything about this car. Just missing T. You can do that. Or if you want, you can look at the trailer on its own. I'm going to do the trailer. Well, we should fit it all in here. I'm going to do the trailer because the trailer has one less force, no engine. So this trailer has 300 kilograms. Something's pulling it. The tension in this rope is pulling it. Something's pushing against it. That's 150 resistance force. Again, friction under the road or air resistance. Don't care. 150 newtons. But here's the thing. If this whole system is accelerating by 0.075, then the car is, then the trailer is, they're all doing it. The total acceleration here is 0.075. So that's A. So I know the total force. The total force in this system must be, I don't really have enough room. F is equal ma. So F must equal 300 times 0.075. Sorry, I know you can't see that, but that's just this number here. Multiply these two together and we get F is equal 22.5. So these two forces must add together to get 22, because these are the only forces here. They must add together to get 22.5. It's a positive, he's a minus. So what must T be? T must be 22.5 bigger than this. T must equal 172.5. And that's the full answer. You could have done this for the car as well. The car had a 1700. It has a force from the engine, which I think we worked out somewhere, didn't we? 700. It has a resistance force of 400. And it has the rope pulling it, T. So again here, you could work out this one as well. You'd need to find the total force from this acceleration and this mass. It would be a different number, but you should find the same T, because the two T's should equal. I hope that answered any problems you had. If I didn't, ask me in the comments below. I'll do my best to answer. Thanks for watching and have a great day.